Okay. All right, so let's look at what classes we currently have created. We have our dungeon, where a dungeon is going to be an array of rooms as well as a starting room. And we decided last time that maybe we have an initial maximum number of rooms that we are dealing with. So the constructor for this guy just goes ahead and initializes our array to be able to hold max rooms, number of rooms. We haven't actually put any rooms in there yet. And then we initialize our starting room to nothing because we also have not set this dungeon starting room. All right, so now to make sure all this works, we also then have to invent our room class. So we wrote room class here, and right now our room's just going to be a name. So we create it with the name, we set the name, and we talked last time about this. We started talking about public, private, protected, and I mentioned that private means you can only access that variable inside of the class named room in this case. All right, so that means if I'm outside here, I think we use an example. If I'm outside the room class right now, I'm inside of main.java. Then if I try to say, I have two rooms, R1 and R2. If I say R1.name, it's going to scream at me because I'm trying to access this private name field from a class called main when it's defined as a private field inside of a class called room. By being private, it's only accessible inside of this class called room. So by putting private in front there, we make these two lines illegal. All right, so now if we wanted to give ourselves access to a private field, this has more to do with us not being able to directly change a field. We make them go through some sort of, because having it public or having it package level, so if I just took this guy off, now the security is package level. Now I can change it, I can read from it or write to it anywhere inside the package without any consequence. I don't get to check to make sure you're setting the name to something that has enough characters in it, or make sure it doesn't start with numbers or spaces or anything like that. Any rules I might want to have associated with it, I don't have an opportunity to do any checking. By making it private and then having a function called like something like set name, you can name it whatever you want. This guy would typically be called a getter or mutator, is kind of the historic term for it. Today we call them getters and setters. Historically, they would have been mutators and accessor methods. But this is just a vocabulary term. It doesn't have anything to do with Java specifically. Just modernly, we call them getters and setters. Sorry, I keep taking breaks because I'm admitting people into the class. So in any case, so because I made it private, if I do want to give somebody externally access to change this private field, which is only accessible inside of the room class, I would have to give them some sort of function. In this case, I called it set name, that takes a string as a parameter, and that would make that guy at least package level. In this case, they made it public so everybody can access it. So externally, anybody can access set name, which then gives internal access to this private field name. And what we might do in here, just to show a real use for this, we might say if name.length is greater than 0, for example, then we'll let them go ahead and change the name. So now we're adding a little bit of logic in here. Like if they want to externally set the name, we check to make sure it's not the empty string before we just go ahead and set it. Which means now out here in main, I can say r1.setName, and because I'm passing it a string that has 3 characters in it, it works. r2.setName has 4 characters in it, it works. But if I try to say r1.setName and I pass it the empty string, it won't actually change the name. Because now empty string is passing in right here. Name.length will be equal to 0. So 0 is not greater than 0. So we will not actually do this. All right. So that's a reason why we might make something private. And as a rule of thumb, I say that fields should always be private. And then if you need to loosen the reins a little bit, and we'll see an example of that when we get into inheritance, you can do so. But start it off as private and then see if you run into any walls. All right. But for right now, we actually don't even need this set name thing. Because at this point, we don't see any reason that we need to change the name of a room. We might have to add that feature in later. But I'm going to go ahead and just to keep our classes as clean as possible, I'll go ahead and dump that. You do still have that code through the link that I posted on Slack last class. All right, we'll come back out here to main, and we're going to go ahead and dump these dudes. All right, so now let's go ahead and create our other classes. So we have our dungeon, we have our room. So now we need to have an exit. An exit is going to be a door leading in a direction to another room given that direction. So that means, I gotta admit somebody else. So let's go ahead and create our class called exit. So new file, exit.java. I could just call it class exit if I just want it all to be in a single package. Not going to make any difference for what we're doing here, but you could make it public class exit if you wanted it to be accessible outside of the package. But that's nothing we're going to run into. I made all the other ones public, so I'll just keep this one public as well. All right, and an exit is going to have a direction, and then it's also going to have a destination, a room that it leads to. So again, fields will start off as being private and only loosen it if we need to. So we'll say private string direction, and we'll say private room destination. Okay, we'll actually call it destination room, just for the sake of being verbose, I guess. All right. So again, differences from C++. Notice we didn't have to include the room.hpp or anything like that. We also, with the syntax for room, we didn't have to put the little asterisks here or anything. It figures out that we're dealing with a memory address. We'll go ahead and create the constructor for exit. Constructors are the same name as the class name, just like it was in C++. And to construct an exit, we're going to need a direction and a destination. So we'll take in a direction and we'll take in a destination. And we'll go ahead and set this dot direction equal to direction and this dot destination equal to destination. All right. Not going to do anything else with that at this point. But now we have the ability to create an exit with a direction and a destination.
I had a question.
Sure, go ahead.
So for C++, we also had a room source room. The source room for the exit. Are we going to do that for this one?
Why would you ask me?
Yeah, probably when we take it. When we take the exit, we might have to pass in the room we were coming from.
Okay.
So when you take an exit, you might pass in the room you're currently in so that it can remove you from that room and throw you into the next room. I'm thinking that's what we wrote last semester. That's why we had that was probably in a function called something like take exit.
Yeah, I think something like that.
Yeah. We probably will have that. Just right now, I like when I write code, I like to kind of, I mean, I'll think a little bit ahead if something makes sense immediately, but right now we haven't started needing to take an exit yet. So I'm not going to write take exit yet until we need to invent that, just to make sure that it's compatible with whatever decisions we've made up to that point. But
Okay.
probably the question you're asking is the answer is probably we will do that.
Okay, cool. Thank you.
Yep. Okay. So let's just leave exit like that for right now. So now that supports this syntax where I can go ahead and say, well, I can say exit E is equal to a new exit and maybe pass in west, and for whatever reason to the west leads to R1. Okay, we haven't quite meshed these things together yet where we're adding exits into rooms quite yet, but for right now, with this syntax at least should work. All right, so there's our program, doesn't have any output, but just to remind ourselves here. I'll go ahead and print out R2, R1, R2, and E, and we'll see 3 memory addresses, which reproves to us that pointers exist in Java. All right, so far, so good. So we'll leave exit like that for right now, and we'll add stuff as we need to add stuff. So we're just kind of building a skeleton set of classes to support all the things that we're going to ultimately glue together. All right, so now I'm going to go ahead and create player and monster separately, and then we're going to talk about inheritance today, and what that might mean. Okay, so we're going to go ahead and create a class player, and a player is just going to have a name initially. So here's our player.java, and we'll say public class player, and we'll say private string name. We'll have public. Here's our constructor player. He'll take a name in as a parameter, and we'll just set that private field equal to whatever was passed in. This dot name is equal to name. Remember, in C++, we would have done that. So arrow that no longer exists in Java. Instead, this dot name goes ahead and dereferences this field, because technically in C++ we would have also said that a string pointer. Actually, technically, with strings we wouldn't have, because it did some fake out for us. But you get the point. All those things have disappeared in Java, where it figures out how you want to deal with memory and just kind of makes it work. For good reason, because 99.99% of the time, what I meant here is to set this string equal to whatever was passed in here. So that's a pretty strong guess that Java can just make. All right, so we're going to go ahead and say that's player for a minute. Similarly, we're going to create a monster, and right now monsters are also only going to have names. We'll add to that here in a little bit. So we'll have a monster.java. So here's our public class monster. We'll have a private string name. We'll have a public constructor. Notice constructors do not have return types, just like they did not in C++. This guy will take a name in as a parameter, and we'll set this dot name equal to name. All right. So now, just to test all these things out, make sure we have decent syntax here. Let's just go ahead and create we'll say player P is equal to new player, and we'll say Mike. And then monster M is equal to new monster. And this is going to be Mr. Gonzalez. Because obviously he's going to be wandering around our dungeon, and he's extremely dangerous. He actually is usually already in the room, but he must still be in bed, actually. He's my doll, for those of you who forgot. He's my elf on the shelf. All right. So in any case, so the syntax should all work, no errors here. We just have kind of our starting point for our all of our classes. All right. So any questions so far? I would say this would have been sufficient for the homework assignment. If you wanted to screw around with inhabitant, some you could have. We're about to introduce inhabitant here in a second.
Why don't you give? Oh shoot! We're all in the same room. It's active. Okay, yeah. So why don't you give the monster and the player like different like names? Like you just do both. Give them the class or the parameters name. That's it.
Well, because a player has a name and a monster has a name. So, there's no real reason to name this variable just artificially a different variable when the meaning of this variable is the name. When I built them, I gave my player the name Mike and I gave my monster the name Mr. Gonzalez. So they do have different names when I built them, but the internal variable, this constructor is expecting a name, so I called it name. This constructor is expecting a name, so I called it name. This class is expecting to keep track of a string called name for the name of this monster, so I called it name. This class is expecting to keep track of a field called name for the name of this player, so I called that name. So this kind of goes back to our discussion from last semester when we said, well, why not do something like this? We'll call this guy player name. Just so I don't have to remember that this syntax thing, why don't I just make sure that this variable and this variable have separate names? You can do that. In fact, you find too many people even professionally do that just for that reason to make this compile. But the reality is that if this is a class and you're holding the name is a very good name for that variable. So you don't have to just artificially create different variable names when they all mean the same thing. All right, that makes some sense. All right, so for right now, we want to kind of look at player and monster pretty closely. And we've already written this in code, but let me draw a little picture to kind of drive this point home. All right, so now we have a player. And a player has a field called name. We have a monster. And a monster also has I thought you were going to bring Mr. Gonzalez in. Well, I've been referencing him in class. My wife refuses to play along. All right, so we have players and monsters here. And notice that for all intents and purposes right now, they are identical to each other, right? Basically, all they are is a name. Now, presumably, if we go back to our plan here, players are going to be human controlled and monsters will be computer controlled. So we might assume that as this evolves a little bit, we're going to have maybe some different stuff inside of those classes. But at the very least, we can say that both of these classes share a common trait. Every player and every monster has a name. All right. So what we can actually do is we can maybe create a class called inhabitant. And I'm gonna make that guy that color. Actually, let's make him. Actually, I'm gonna make him this color for now, and I'm gonna switch it to red in a few minutes. All right. And if we do that, and we say that a player is an inhabitant and a monster is an inhabitant, and they will go ahead and get that top level ability from inhabitant. Now, let me go ahead and show you how you actually make this occur. We go into our code here. I'm going to create another class called inhabitant.java. All right, this is going to be public class inhabitant. And this guy will have a private string name. We'll have a public inhabitant that takes a string name as a parameter. And we'll say this dot name is equal to name. Okay, effectively right now, I have three classes, player, monster, and inhabitant, that are effectively written identically. All right, but now to support what we've done in this picture, we're going to go ahead and say, you know what? I want player to be an inhabitant. I want monster to be an inhabitant. And all inhabitants have a name. So what we're going to do is inside of player, I'm going to get rid of that field. Inside of monster, I'm going to get rid of this field. And then what we're going to do is we're going to say player extends inhabitant. We're going to say monster extends inhabitant. So that means monster gets everything that an inhabitant has, but then he can differentiate himself, and we'll look at that here in a few minutes. And a player gets everything that an inhabitant has, and then he can choose to differentiate himself a little bit. And we'll do that again in a few minutes. Okay. So even though, let me just go ahead and run this real quick. Go back to main. We have our player and our monster. We go ahead and run it, and we get an error. Why do we get an error? Notice it's, go back here. Notice it's complaining about private access. In inhabitant, I made this string name private. Remind me, what does private mean?
Means you can only access it within that class.
Yeah, private means we can only access it inside the class called inhabitant. So I have a string called name that I am now trying to access inside of player. I'm also trying to access inside of monster. And at the very least right now, we can say that monster is not the class inhabitant and player is not the class inhabitant. So we can't actually access this private string in those two classes. All right, makes sense why we're getting the error for right now? All right, I'm just going to take private off there for a second. We'll go back here, we'll run this again. Oh, I didn't write my constructor for inhabitant. All right, so the error we're getting here actually leads up to what I'm about to show you. What's happening at the beginning? So whenever we extend the class, right now, as I've written this, I'm trying to set the name itself directly, yet I already have a class called inhabitant that has a constructor that sets the name for me. So what I can do, and I'm actually going to show you something that's magically already here. That is, you can imagine that is invisible right now in both of these classes. So right now, invisibly, the very first line of the constructor and monster and the constructor of player, it is trying to call the constructor for the parent class with no parameters. Now notice that my constructor for the parent class currently does take a parameter. Now, if I take this guy out and then I run this, well, he's complaining because I didn't actually write a method called that. It's fine for right now. But notice that he is trying to call that. Actually, let me just take those out for right now, just so this goes fully, I can fully explain it. So trust me, those are invisible right now, but they're actually invisibly written slightly different that I'll show you in a second. So there's something invisible being called here. That is the parents constructors being called with no parameters. There's something invisible right here being called. That is the parents constructor being called with no parameters. Inside of inhabitant, I haven't actually written a constructor. And because I haven't written one, a no argument constructor is created for me, just like in C++. So what we're going to see here is what happens by default. And then I'm going to show you how we practically should do it. Okay? Because right now it just happens to be compiling. It really doesn't make much sense what's going down right now. All right? So this compiles right now because I have not written any constructor inside of inhabitant. So a super secret constructor called public inhabitant that takes no parameters was created for me. So it's as if I wrote this right now. All right. And that syntax is there to support me creating instances of things that are inhabitants. So it happens automatically for us to support that syntax, even though you would likely never rely on this. Okay. So right now, when a player is built, there is a hidden thing right here that looks like that. For monster, there is a hidden thing right here that looks like that. I'm going to go ahead and run this real quick. Okay, see, he's happy again. So right now, the very first line of player, even though you didn't have to write this, what it first does, since a player is an inhabitant, that means he's everything that an inhabitant is as a starting point. The very first thing that happens in the constructor for player is we call our parents constructor. And if I don't make a call to my parents constructor, it will assume that my parent has a constructor that takes no parameters. If this is how an object refers to itself from within itself, super is how an object refers to its parent from within itself. So let's add that to our notes. Super keyword. Kind of like this. This keyword. This is how an object refers to itself from within itself. I'm going to say this keyword. Super keyword is how an object refers to the instance of its parent from within itself. Okay, Now let's keep going down the rabbit hole a little bit to really connect this idea of how objects are put together. We've actually already talked about this several classes ago when we talked about that toString method and why things give us outputs that look like these memory addresses. So if we go back to room here, I promise you that hidden here at the top of the room constructor is super. I'll go ahead and run this and prove to you this guy still works. Okay, similarly, at the top of the dungeon constructor, the very first line is hidden, a call to his parents constructor that takes no parameters. Same thing in exit, there's a call to his parents constructor that takes no parameters. I'll go ahead and run this again, still see it runs. So kind of proving that yes, those things were being called even though they were hidden from us. Okay, Java does a lot of this. Things that always need to be written a certain way, Java doesn't require us to write it. And usually we're going to write it differently anyways. Okay, and we'll see that example here in a minute. All right, now we've drawn a picture over here that we've decided that, you know, a player and a monster are both inhabitants. And I'm just going to label this. This is called inheritance. All right, so this is an example of inheritance. This is the parent class. This is a child class. This is another child. I'll just put it underneath. That's a child class, and this is another child class. Both of these guys extended this parent class. All right. And we saw that happen in code. When we went to inhabitant, we created this class called inhabitant. And when we built monster, we said class monster extends inhabitant. That's the magical syntax to say that this guy has a parent called inhabitant. Similarly, player extends inhabitant. That makes this picture true. All right, any questions about that before I try to trick you? All right, so we saw in both player and monster right now that magically where this line right here, super, is being passed. That is, this guy creates the instance of the parent class. And this always happens as the very first line in a constructor, even if you don't write it. Because presumably after we have our instance of the parent class, then we start differentiating ourselves. All right, we don't quite have this written the way we want it written quite yet. I just want to drive this point home about how this inheritance model works. All right, so we can put this comment next to every single one of these classes. So even though we didn't have to write it, we're just revealing something that was hidden from us. It was written. All right, and we see everything still works. All right, so if we're in player, the parent is inhabitant. If we're in monster, the parent is inhabitant. What if I'm in room? Who is the parent? We see it works. We're not getting an error here. Who's the parent of room?
Is it main?
Nope, not main. if I wanted it to be main, which it wouldn't make sense in this case, I would have said extends main. So not main. So what I'm really implying here is there is something hidden. There is something that we're not seeing that's actually typed in right here. Because we didn't type in something special like we did here. We specify that we want to extend inhabitant. We specify we want to extend inhabitant. We didn't specify anything here, or for that matter, here in inhabitant. So who is super related to room? We've actually already looked at this, but I'm kind of completing the loop by you seeing the other side. So it's not necessarily surprising that you're having trouble making the connection.
I think a few people in chat have already said this too, but is it the generic class object?
It is. It's a generic object. So when we come back here, technically, every single time we ever create a class, inheritance is actually happening. So even though we didn't use that extends keyword here, this guy extends object. That's what's actually there. Which means that above this, we have object, which might have some fields in it, but as far as we know, there's nothing. So this is the top level class. Every single object that exists in Java, whether we created it ourselves or it was built into Java, at its, it's either its parent, or in this case, its great grandparent, or in some cases, it might be its great great grandparents, so on and so forth. At the very top level of that hierarchy is this generic object. And we saw that in the Java documentation. Just get to string here and I'll go to java.lang real quick. Scroll down to object. All right, so notice here, if I choose number, notice that number is an object. If I choose, I don't know, string, notice that string is an object. But if I choose object, notice this guy is nothing. The buck stops here. All object-oriented languages, and this is something that we learned about in the 470 class, the language theory class, where we write a programming language, is the core of an object-oriented language is there has to be a beginning. This dude has to be built into the language. You can call it whatever you want. Some languages, it's object with a capital O, C#, it's a lowercase o. Usually it's one of those two, but they can really call it whatever they want. But this guy has to be built into the core implementation of the language in order for every other class to exist. Now, when we look at what's inside the object class, because we didn't write it ourselves, we see that it doesn't have a whole lot of stuff in here. Basically, what this is the absolute minimum that must exist in the Java language, or that they've decided must exist in the Java language to support object-orientedness. Every single object should be able to clone itself. It should be able to compare itself to something else. Where we first talked about it was with this toString method. Every object has a toString method. The default toString method prints out that memory addressy looking thing. But if we write a newer version of that toString method, so for example, if I go back to my code here, notice here in main, we are calling println on an exit, for example, E, and we're getting the memory addressy thing right here. If I go into exit and I say public string toString and I return LOL here, what I'm doing here is I am overriding the toString I inherited from object. And because I did that, I'm saying use this version of toString instead of the default one that came from my, in this case, my parent, which was object. So now we'll see if I go back here and I just run the code again, this last line will no longer look like a memory address. It'll now say LOL. Because I changed how exits work. I said, you know what? If you try to print an exit, print calls toString. That's what he does. He is able to call toString because he knows that every single object will have a method called toString. What's happening right here when I say println E, it's calling the toString method of E. That's what it's doing. Again, it's hidden. Okay. It knows it can safely call toString of any object because toString is a method that exists in the top level object class. So it makes that system.out.println work for any object, with the default behavior being of the toString for object, that guy being print out weird memory address thingy. This kind of thing. Okay, so that's what's actually happening there behind the scenes. So in our picture right here, we have a player, which is an inhabitant, which is an object. We wrote inhabitant, we wrote player. Some microsystems people wrote object. But even though we didn't actually tell inhabitant that we want him to extend object, extends object is written here. Hidden. You can write it if you want, but the idea is every single top level class that we write will always automatically extend object unless we specify otherwise, like we did here. So if we don't specify anything, it's as if we wrote this. All right, so we're kind of closing the loop on how these things work. Now, if you remember from C++, we also did not have to write the equivalent of extends object. It was done automatically for us there too. All right, so C++ did do some stuff for you. It just didn't do everything that Java does for us. If you look at another language like Objective-C, Objective-C uses a little bit different syntax, but it would have something like that. Inhabitant inherits from object. And it does make you do that. Actually, if you're doing Objective-C, it's actually called an NS object. All right. Anybody know why it's called an NS object on Mac? I'm sorry, an NS object in Objective-C. Interesting computer science trivia thing here. So in our last little 4 minutes here before I go any deeper, we'll start off next time by implementing the monster and player the way we really should be implemented. Actually taking advantage of our inhabitant. But NS object. So we have Apple Computer, right? Now, way back when C++ first came out, Microsoft went the C++ route, Apple went the Objective-C route because they hated each other, so they always just pick the opposites, right? Now, Apple Computer fired Steve Jobs. I don't remember if I mentioned this in the last year's class, but I'll just go through it again here anyways, because it's a very interesting history thing that isn't what you think. What did Steve Jobs do when once Apple fired him? Anybody know?
You go to Pixar.
He bought Pixar from so he did purchase Pixar. He didn't go there. He did create another company though. Anybody know what company he created? Show you a quick picture here. Steve Jobs, next computers, images. There you go, Steve Jobs, next computers. So he created, this was when he was fired from Apple. He created this computer company called Next. Created Next Computers. During this time, Apple started to fail as a company. Did Apple rehire Steve Jobs? Because before Steve Jobs died, he was the CEO of Apple, right? So did they bring him back? What do you think? Apple acquired Next Computers, which came with Next CEO, Steve Jobs. He was given the title interim CEO, which in the early days of things like iPod and things like that, he was nicknamed the iCEO. And then he just never left, right? Steve Jobs actually made Apple payroll for almost a year out of his fortune because Apple would have folded as a company. Now, what's really interesting here is if you go and look at the documentation today, this is modern. This is developer.apple.com. So this is their documentation for their Objective-C and their Swift programming language. We have this thing called NSString, which inherits from NSObject. What do you think NSObject is? Next step object. What does that tell us? Apple today is Next Computers with an Apple logo on it. Most of you didn't know that Apple died a while ago. And what we call Apple today is actually Steve Jobs' company, Next Computers, with an Apple logo sitting on the front of it. Pretty interesting history type thing. All right, questions, comments, concerns. This is a really neat thing about the history in our industry that most people don't know about. One of the richest companies in the world right now is a company that people don't even know existed. All right, so I will see everybody on Wednesday. No homework for Wednesday, but let me just put a little reminder for myself. We're going to start with create inhabitant correctly. All right, we're going to show it the use, how we should use that inheritance model in our current example. All right, questions, comments, concerns, bribes. All right, I will see everybody on Wednesday.
6 months in advance.
Have a great day, sir.
Nobody
Yeah.
looks at apartments.
And I'll post today's code up as well, just so you have access to the current state of things.